Okay, we want to talk about selecting a committee of 3 from a group of 5. So you have 5 people, you're going to select 3, and the 3 are going to be selected, and the order in which they're selected doesn't matter. So how many ways are there to select 3 people out of 5? Can you apply the fundamental counting principle? What can you do? Think that through. I'm going to pause and write a little more. Hopefully it'll match what you've been able to figure out. Okay, first thing you got to see is there are 5 choices for who's chosen first, 4 for who's chosen second, 3 for who's chosen third, and that should be fairly obvious. And that doesn't matter who was chosen for the first. Makes no difference at all. There are going to be 4 choices left for the second because there's no restriction on who can be chosen at any point, except that your choice can't be the same as a person that's been chosen previously. Now, so how many possible ways are there to choose the 3 people? We can see that the fundamental counting principle applies, so there are 5 times 4 times 3, or 60 possibilities. Now, is that the number of groups of 5, or the number of committees of 3? And the answer is it's not. It's too many. And why is that? Think about that for a second. It isn't too difficult to see why it is that there really aren't 60 different possible groups of 3. Because a group of 3 consists of 3 people, and those 3 people could be chosen in any number of orders. If you have 5 choices for the first, 4 for the second, 3 for the third, that means person A, person B, person C, person D, person E could be chosen. If we let the people be A, B, C, D, and E, any of those people could be the first one chosen. Now let's suppose that person A, person B, and person C are the 3 who are chosen. How could that have occurred? Well, A could have been the first one chosen, and B could have been the second, and C could have been the third, in which case we would have had A, B, C in that order. However, it's also possible that A was chosen first, B was chosen second, and C was chosen, A was chosen first, C was chosen second, B third. Or BAC in that order, BCA, CAB, or CBA. There are 6 possibilities, and they all lead to the same committee. Okay, so there's 6 possible ways that that committee could have been chosen. Now, there are 60 possibilities, but for any one group of 3, there are 6 ways that that group could have been chosen. So how many possible groups are there? Okay, our 60 possibilities includes every possible order. There's 60 possible ordered choices then. But any group of 3 is going to appear in 6 possible orders. So it's going to be included among the 60 6 times. So how many possible groups are there? The answer is 60 over 6 possible. That's 10 possible groups, committees. Now the number of possible order choices then is 60 over 6. The number of committees is 60 over 6. The number of possible order choices is 5 times 4 times 3, or 60, as we understand. We can write that 5 times 4 times 3 as 5 factorial, which is 5, 4, 3, 2, 1, divided by, well, we have to get rid of the 2 times 1 to leave us 5 times 4 times 3. So we divide by 2 times 1, and that gives us 5 times 4 times 3. Then, in terms of factorials, how would we write the number of possible committees. Now the number of committees is, as we saw, 60 over 6. In terms of factorial, 60 is 5 factorial divided by 2 factorial, and 6 is 3 factorial. And we could write that as 5 factorial over 2 factorial times 3 factorial. And might as well write this out. 5, 4, 3, 2, 1 over 2 times 1 times 3 times 2 times 1. The 3 times 2 times 1 can be divided out. 2 goes into 4 twice, so we end up with 5 times 2, which is equal to 10.